students, welcome back to Diksha Vedantu English for 9th and 10th. I'm your chemistry master teacher Ankitha. Today we are going to discuss all the important PYQs, the most repeatedly asked questions, most frequently asked questions in chemistry. Okay, in under 30 minutes. So without any further ado, let's get started. Please do subscribe to the channel and comment in the live chat so that I can respond to you. Okay, if you have any doubts, you can let me know. Guys, let's start with chemistry first. Okay, I'm your chemistry master teacher Ankitha. Let's get started without any further ado. First chapter, chemical reactions and equations. So the first question. So what is a redox reaction? This is the very first question and this is one of the most important questions. So how do you define a redox reaction? We know what is oxidation. We know what is reduction. So when both oxidation and reduction reactions occur simultaneously, it is called redox reaction. A redox reaction is defined as a reaction. So it's a reaction in which oxidation and reduction takes place simultaneously. So in fact, both these processes takes place simultaneously. It's called redox reaction. Example, copper oxide undergoes, redox reaction with hydrogen. It is going to give copper and H2O. Okay, copper is undergoing removal of oxygen. It is nothing but reduction. Okay, copper oxide is undergoing reduction and hydrogen will be undergoing oxidation. Next, what is rancidity? Rancidity is nothing but the oxidation of oils or fats in food resulting in bad smell, that is odor, as well as bad taste is called rancidity. How can we reduce the problem of rancidity? So adding antioxidants and also storing food in airtight containers. Refrigeration of food also helps in slowing down of rancidification. Okay. Next, what is corrosion? So how do you define corrosion? Corrosion is nothing but the natural process of deterioration of metal surface by the action of different gases as well as moisture content. So corrosion in case of iron is called rusting. Okay, so let's see the answer now. So what is the answer? When some metals are exposed to moisture, acids, etc., they tarnish due to the formation of respective metal oxide on their surface, or they corrode. We can say corrode or deteriorate. Any word can be used here. Okay. So this process is called corrosion. Corrosion can be prevented by painting the surface, oiling, greasing, galvanizing, chrome plating, as well as making alloys. So these are the various methods of preventing corrosion. Next, in electrolysis of water, why is the volume of gas collected over one electrode double that of the other electrode? So if we see water molecule, there are two hydrogen atoms and one oxygen atom. So that is the very reason during electrolysis of water, electrolytic decomposition of water, so we'll get two molecules of hydrogen and one molecule of oxygen. Okay, so this is the answer. So moving on to the next one, what are precipitation reactions? Are all double displacement reactions are precipitation reactions? No. Okay, so for the second question, it is no. Not all double displacement reactions are precipitation reactions, but precipitation reactions are a type of double displacement reaction. So a reaction in which an insoluble solid substance is formed as a product is called precipitation reaction. Okay, yes, see here. So what are precipitation reaction? The reactions in which a solid, an insoluble solid substance is produced as a product, is called precipitation reaction. As a product is called precipitation reaction. No, not all double displacement reactions are precipitation reactions. I'll give you example. Neutralization is a type of double displacement reaction. Okay, when NaOH reacts with HCl, here also exchange of ion happens, leading to the formation of NaCl and H2O. But this NaCl is not a precipitate. Okay, so not all double displacement reactions are precipitation reactions. Next, define displacement and double displacement reaction and give examples for each. So you know very well the definition of displacement reaction. So the more reactive metal is going to displace the less reactive metal from its salt solution is called displacement reaction. Double displacement reaction, exchange of ions is going to happen. What's going to happen? Exchange of ions is going to happen. Example for the displacement reaction, iron is reacting with copper sulfate to produce ferrous sulfate and copper. So this is blue in color, okay? The product will be green in color. Ferrous sulfate is green in color. As iron is more reactive than copper, iron is placed above copper in the reactivity series. So this reaction is going to happen. And double displacement reaction, we have copper chloride and AgNO3, that is silver nitrate. They are going to exchange their respective ions to form a precipitate, okay? Copper nitrate, CuNO3 twice, and AgCl. AgCl. So this can be given as the example. You can give this as the example for, as an example for double displacement reaction as well. Moving on, acids, bases and salts. This is the second chapter. First question, mention the preparation and uses of baking soda and washing soda. So how do we prepare baking soda? Baking soda is nothing but NaHCO3, sodium bicarbonate. Washing soda is nothing but Na2CO3, 10H2O, sodium carbonate decahydrate. There are 10 molecules of water of crystallization here. So this process is also called, what is it called, guys? So it is called solvay ammonia process. Solvay ammonia process. Okay, this is the preparation method in order to prepare baking soda, that is sodium bicarbonate. So we are going to take brine solution. Brine solution is nothing but highly concentrated aqueous solution of sodium chloride. Okay, we are going to introduce that into a carbonating tower, and all these reactants are made to react with ammonia, leading to the formation of sodium bicarbonate, and NH4Cl, ammonium chloride, is the byproduct. Okay, and what are the uses of baking soda? We can easily say, so baking soda is used to make baking powder. It is used in soda acid fire extinguisher. It is used as an antacid, one of the components of antacid, in order to cure acidity or gastritis. Next we have baking soda, washing soda preparation. So this NaHCO3 that is obtained from solvay ammonia process is made to heat. Okay, it is subjected to high heat. Okay, it is going to give sodium carbonate, carbon dioxide and water. This sodium carbonate is going to be recrystallized. Recrystallization is going to happen. Recrystallization of sodium carbonate, okay, with water leads to the formation of sodium carbonate decahydrate, which is nothing but washing soda. So what are the uses of washing soda? Washing soda can be used as a cleaning agent. It is used in shampoos. It is used in cleaning agents. Okay. Moving on to, what is the common name of calcium hypochlorite, that is CaOCl2? How is it prepared? Very simple. It is nothing but bleaching powder. Bleaching powder is used as a disinfectant. Alright. And chlorine gas is passed over dry slaked lime, that is nothing but calcium hydroxide. So yes, Cl2 gives, what do we get? CaO, Cl2 and H2O. This is the reaction. Always, whenever they ask you to explain a process, you have to make sure that you are writing the balanced equations. Why don't we keep salt substances in brass and copper vessels? So in the first chapter also we have discussed this. Acids are going to react with metals, right? So metals that are placed above hydrogen in the reactivity series are going to react with the acid, metals. Yes. Acid combine with metals to form salt and hydrogen gas. When salt, things such as curd has lactic acid in it, right, are stored in brass or copper vessels. The lactic acid in the curd reacts with the metals, causing corrosion and creation of toxic salts, okay, which cannot be digested. That's why we do not keep salt substances in brass and copper vessels. Okay, the metals are going to react with the acid and they form salts, respective salts. So salts are not good for the health. Not all salts are good for health. It cannot be consumed. That's why. Moving on to explain pH scale. This is very, very important, guys. When they ask you to explain pH scale, you mention what is pH. pH is nothing but power of hydrogen. Okay, and pH is inversely proportional to the concentration of H plus ions. Okay, this is something that you need to mention. It is nothing but, pH is nothing but power of hydrogen or potence of hydrogen ions, and it is inversely proportional to the concentration of H plus ions. And you can, mention the use. pH scale is used to measure the basicity or acidity of a substance. Okay, pH scale ranges from 0 to 14. So below 7, it indicates acidic substance. Above 7, if the pH is equal to, equal to above 7, then it means that the substance is basic in nature. Okay, and if pH is exactly equal to 7, then that substance is a neutral substance. So the pH scale is commonly used scale to measure the acidity or the basicity of a substance. The possible values of the pH scale range from 0 to 14. Acidic substances have pH values ranging from 1 to 7 or 0 to 7, 0 being the most acidic point on the pH scale, and alkaline or basic substances have pH values ranging from 7 to 14. Okay, 7 to 14 means above 7 means concentration of OH minus ions increases. So below 7 means if the pH is below 7, concentration of H3O plus ions increases. Okay, indicating acidic substance. Now, what is chloralkali process? Write the uses of the products that are obtained from chloralkali process. Chlorine is produced. Alkali is produced. Caustic soda is produced. Right? So, chloralkali process is nothing but when we take brine solution and it is electrolyzed, we are going to get NaOH, chlorine gas, and we get hydrogen gas. Okay, so this is nothing but chloralkali process. I hope this reaction is balanced. Okay, so this is the reaction. So brine solution is electrolyzed to give chlorine gas, caustic soda, that is sodium hydroxide, and hydrogen gas. This is nothing but chloralkali process. What are the uses of the products here? NaOH, sodium hydroxide, is an excellent degreasing agent. Okay, so used for making detergents and soaps, paper making, and artificial fibers. Chlorine gas is used for making bleaching powder, pesticides, as well as CFCs. And hydrogen is used for making ammonia, fertilizer. And also it is used as a fuel. Next, why do acids not show acidic behavior in the absence of water? We have discussed this in Arrhenius acids and bases. Okay. So the acidic behavior of acid is due to the presence of hydrogen ions. H plus ions is responsible for acidic nature of acids. OH minus ions are responsible for basic nature of the bases. Okay, the acids will not show its acidic behavior in absence of water. This is because acids do not dissociate or ionize, okay, to produce H plus ions in the absence of water. That's why acids are not going to show acidic behavior in absence of water. Next, why is plaster of Paris stored in moisture proof container? So you need to have an understanding about gypsum as well here. So what is going to happen here? The plaster of Paris should be stored in moisture proof container because plaster of Paris, it is a powdery substance. Plaster of Paris is powdery. Okay, absorbs water to form hard solid known as gypsum. It will form gypsum. That's why it is not stored in a it must be stored in a moisture proof container. We know what is plaster of Paris: calcium sulfate hemihydrate. Calcium sulfate hemihydrate. If we store this in normal container, it is going to form gypsum. Okay, it is going to form gypsum. Gypsum is nothing but calcium sulfate dihydrate, and gypsum is a hard solid mass. Now moving on to the third chapter. This is the chapter with highest weightage. Okay, metals and non-metals. So it has the highest weightage. All right. So first question, explain the process of refining of metals. This is one of the most, most frequently asked question in your board exam. So yes, explain the process of refining of metals. We are going to take two electrodes, okay, cathode and an anode. So in the cathode, we are going to take something, and anode, we are going to take something. So in the anode, we are going to take impure metal which needs to be purified. In the cathode, we are going to take the pure metal. Okay, we are going to take the pure metal. So we'll take an electrolyte. The respective electrolyte is taken. For example, if we are refining copper, then we are going to take pure copper rod as the cathode and impure copper rod which needs to be purified as anode. Okay, electrolyte will be acidified copper sulfate. It will be acidified copper sulfate. Acidified copper sulfate solution. Okay, in the electrolyte, we already have Cu2 plus ions and SO2 minus ions, which is responsible for conduction of electricity, right? At anode, oxidation is going to happen, guys. And in the cathode, reduction is going to happen. So what's going to happen? Reduction is going to happen. Okay. So from the impure metal, from the impure anode, the copper 2 plus ions are going to the electrolyte, and the copper 2 plus ions that were already in the electrolyte are going to get deposited or get reduced on the cathode. So the size of the cathode increases, the size of the anode decreases. Okay, the size of the anode decreases. All right. And the impurities will be collected at the bottom of the anode, and we call it as anode mud. What do we call them? Anode mud. So reduction, what's going to happen? Cu2 plus 2 electron leads to the formation of Cu. Okay, so this happens at cathode. This happens at cathode. At anode, what is going to happen? At anode, so Cu is going to get oxidized. Cu2 plus 2 electron. This is oxidation. This is oxidation. Oxidation happens at anode, reduction happens at cathode. As simple as that. Okay, so you can take the general example and explain. Next, moving on, what are the differences between calcination and roasting? This is very, very important, guys. So roasting, ore is heated in excess of air. Calcination, ore is heated in absence or limited supply of air. Roasting is used for sulfide ores. Roasting is conducted for sulfide ores, while calcination is conducted for carbonated ores or hydrated ores, which already has oxygen. So we will not be heating the ore in oxygen, or in limited supply of oxygen we are going to heat it. So sulfur oxide is produced along with the metal oxide. This is a gas that is produced during roasting. But in case of calcination, so carbon dioxide gas is produced along with the metal oxide. There is an example here. So zinc sulfide is made to react with oxygen. It is heated with oxygen, in excess of oxygen, to give zinc oxide and sulfur dioxide gas. Here zinc carbonate is heated in limited supply of air or in absence of air to form zinc oxide and carbon dioxide gas. Alright. Next, compound X and aluminium are used to join railway tracks. Whenever you hear railway tracks, welding of railway tracks, you need to remember which reaction? Thermite reaction. Identify the compound X. Which is compound X? It is nothing but Fe2O3. And name the reaction, that is thermite reaction. Write down its reaction. Please do write the balanced equation here. 2Al plus Fe2O3 gives Al2O3 plus 2Fe plus heat. This is a highly exothermic reaction. Exothermic reaction. That is why this reaction is used in joining the railway tracks, in order to melt the metal. Okay, the metal that is obtained here is in molten state. It is in molten state. Moving on, mention some exceptional metals and non-metals. You can easily write this. So exceptional metals. So which are those exceptional metals? We have mercury, which is a liquid metal. Right, mercury is a liquid metal. And what else do we have? Liquid metal, and we have lithium, sodium, potassium. These are soft metals. These are soft metals. Zinc is non-malleable, and non-metals. So which are the exceptional non-metals? I need you to comment in the live chat. Okay, please do comment in the live chat and explain the reactivity of different metals with water. So how different metals are going to react with water? They react differently, right? It is based on their reactivity. So how are they going to do it? Potassium reacts with cold water. Okay, sodium also reacts with cold water. Let me write here. Sodium also reacts with cold water. So there is a vigorous reaction when it comes to potassium and sodium. They are going to catch fire. Okay, next, magnesium reacts with hot water. Calcium reacts slowly with cold water and vigorously with hot water. And calcium is going to start floating on water, because the evolved hydrogen gas is going to deposit on the metal, so causing the metal to float. Next, aluminium reacts with water vapor. It's neither going to react with cold water or hot water, but steam. Iron reacts with steam. Zinc also reacts with steam. So copper does not react with cold, hot or steam. Okay, copper is not going to react with cold water, hot water or steam. Next, silver we have. It is silver, gold, copper. These are not going to react with water at all in any state. Steam or boiling water, that is hot water or cold water. So this is about the reactivity of different metals with water. Next, write the differences between covalent compounds and ionic compounds. So what are the differences between covalent compounds and ionic compounds? So covalent compounds, this is something that we have studied in carbon and its compounds. Ionic compounds, this is something that we have studied in metals and non-metals. Okay, so ionic compounds are formed because of complete transfer of electrons. Complete transfer of electrons leads to ionic compounds. Covalent compounds are formed when sharing of electron happens. Sharing of electrons. Complete transfer of electrons. Here sharing of electrons is going to happen. Okay, so let's discuss that. So covalent compounds and ionic compounds. Ionic compounds are formed by complete transfer of electrons. Complete transfer of electrons. They exist in solid state. Usually ionic compounds exist as solids at room temperature. Covalent compounds are formed by the sharing of electrons between two atoms. They exist in all three states, solids, liquids, gases as well. And ionic compounds have high melting and boiling point, while covalent compounds have low melting and low boiling point. What is the reason? This is also a question. Why covalent compounds have low melting and low boiling point? Because there is weak intermolecular force of attraction between the between the atoms. Okay, in case of covalent compounds, that's why they have low melting and boiling point. And ionic compounds are usually soluble in water, while covalent compounds are not soluble in water. And ionic compounds are very good conductors of electricity. There is a twist, in molten and aqueous state, not in solid state. But covalent compounds are usually bad conductors of electricity. They are insulators. Okay, this is the difference between covalent compounds and ionic compounds. And guys, so the notes will be in the description. Click on that and please do revise it. Okay, please do revise all these questions once again. And generally when metals are treated with mineral acids, hydrogen gas is liberated. But when metals except manganese and magnesium are treated with HNO3, that is nitric acid, it's a strong acid, hydrogen is not liberated. Why? This is also one of the important questions. So what is the reason behind that? Most metals do not react with HNO3 because nitric acid is a potent oxidizing agent. It is going to oxidize. Okay, oxidize the hydrogen gas that is produced. Hence, when metals are treated with nitric acid, hydrogen gas is not liberated. Oh, okay, so hydrogen gas will be oxidized to hydrogen oxide, that is water. Okay, nitric acid is a very good oxidizing agent. But there are exceptions, which is that magnesium and manganese can produce hydrogen gas with very dilute nitric acid. Okay, not strong dilute, or concentrated nitric acid, but dilute nitric acid. Moving on with the last chapter. So, okay. So, we have discussed 3 chapters under 20 minutes. It's only going to take 10 more minutes. Okay, trust me. Carbon and its compounds. So, why are detergents better cleansing agents than soaps? Explain. Why? You already know the reason. Detergents are effective in hard water. On the other hand, soaps are going to form scum, okay, in hard water. So, that is the very reason. Detergents are better cleansing agents than soaps because we can use them even with hard water. The charge ends of detergents do not form insoluble precipitates with calcium and magnesium ions in hard water. But when soap is used for washing clothes with hard water, it reacts with the calcium and magnesium ions of hard water to form an insoluble precipitate called scum. It is going to form scum. So scum sticks to the cloth to be washed. So making cleansing clothes difficult. It's going to be very, very difficult for soap to show the cleansing action because scum is going to be formed. Next, how is ethane prepared from ethanol? Give the reaction involved in it. So how ethane is prepared from ethanol? So ethanol is heated at 443 Kelvin in excess of concentrated sulfuric acid to obtain ethane. Sulfuric acid acts as a dehydrating agent, guys. It acts as a dehydrating agent. And I need you to write the reaction in the live chart. Okay, please do write the reaction in the live chart. That's very simple. C2H5OH. So when it is heated in presence of H2SO4, concentrated H2SO4 at 443 Kelvin, what is going to form? CH2 double bond CH2 with water. This is nothing but, so yes, preparation of ethane from ethanol. Next, which are the properties of carbon that are responsible for uniqueness of carbon? So, small size of the carbon atom. If they ask you this for 1 mark, you need not explain any of these things. But if they ask you to write this for 3 marks, be mindful and explain everything. Small size, catenation and tetravalency. Okay, catenation and tetravalency. Catenation is nothing but it is the ability of the carbon to form bonds with other carbon atoms, or self-linking capacity of the carbon atom is nothing but catenation, small size. So carbon is a very small atom with the electronic configuration 2,4. Even when it forms huge complexes, there is no much interelectronic repulsion. That's why the compounds or the complexes are very stable. Next, tetravalency. Valency of carbon is 4. Okay, it can form bonds with 4 different atoms or 4 carbon atoms. Okay, leading to the formation of huge compounds and various innumerable compounds. Moving on, what is saponification process? Write the balanced equation. Saponification, super important. Saponification as well as the esterification reaction. Yes, saponification is a process of preparation of soaps. On treating esters with sodium hydroxide, which is an alkali, the ester is converted back to alcohol and sodium salt of carboxylic acid. This sodium salt of carboxylic acid is nothing but soap. Okay, this is nothing but saponification. Okay, so CH3, COO, C2H5. What is that? Ester. Okay, ethyl ethanoate is reacting with sodium hydroxide to form what? CH3COONA, sodium salt of carboxylic acid, and C2H5OH. This is nothing but saponification. And how do we distinguish between saturated and unsaturated hydrocarbons? So saturated hydrocarbons are going to burn with a blue flame, clean blue flame. Unsaturated hydrocarbons are going to burn with a sooty flame, or it gives yellow flame. But there is a twist here. What is the twist? So even saturated hydrocarbons are going to give soot when insufficient supply of oxygen is there. Alright, and saturated hydrocarbon undergoes substitution reaction. Okay, this is substitution reaction. CH4 plus Cl2, in presence of sunlight, it is going to form CH3Cl plus HCl. But unsaturated hydrocarbons are going to undergo addition reaction. So addition of hydrogen can happen. Addition of bromine can also happen. Addition of hydrogen to ethene. So it is going to form ethane. Okay, so saturated hydrocarbons are going to undergo substitution reaction, while unsaturated hydrocarbons are going to undergo addition reaction. Next, esterification process, and you need to write the balance equation here as well. So esters are most commonly formed by reaction of an acid with an alcohol. Ethanoic acid, so this is the reaction that is present in your textbook. So ethanoic acid reacts with absolute ethanol in the presence of an acid catalyst to give an ester. This is the reaction, CH3COOH. What is that? That is ethanoic acid is reacting with ethanol. Okay, in presence of an acid catalyst, which is that? H2SO4. H2SO4, okay, to form so ethyl ethanoate and H2O. And last but not the least, explain cleansing action of soap. Here you need to describe micelle formation, guys. Micelle formation. So in order to describe micelle formation, you need to know two things. So this is the hydrophilic end. Hydrophilic end. Okay, this is the ionic end of the soap, ionic end. While this is the hydrophobic tail, hydrophobic tail. So what is this? This is carbonyl group. This is carbonyl group. We already know what are soaps. Soaps are nothing but potassium or sodium salts of long chain fatty acids. So this is the ionic end. It loves water, hydrophilic. Okay, water loving. Water loving. And this hydrophobic, water hating end. Water hating. Then you can explain easily. Okay, so how do you explain that? Let me erase all of these things. Yes. So soaps are molecules in which the two ends, one is hydrophilic, that is it interacts with water, while the other end is hydrophobic, that is it interacts with the hydrocarbons. Okay, or the hydrophobic means it can interact with the oil, grease or dirt molecule. So when soap is at the surface of water, the hydrophobic tail of the soap will not be soluble in water, and the soap will align along the surface of water with the ionic end in water and hydrocarbon tail protruding out of the water. This is how it looks like. So this is the dirt. I'll represent this in yellow color. This is the dirt. Okay. And this is a soap molecule. This is the carbonyl end. This is the hydrophilic end. That is the ionic end. This is nothing but micelle formation, guys. This is an emulsion. Okay, so this is nothing but emulsion. This is micelle formation. Okay, so out of water, inside water, these molecules have a unique orientation that keeps the hydrocarbon portion out of the water. Thus, clusters of molecules in which the hydrophobic tails are in the interior of the cluster and the ionic end are on the surface of the cluster. This is ionic end. It is protruding outside. Okay. So soap in the form of micelle is able to clean since the oily dirt will be collected in the center of the micelle. Thus, the dirt in the micelles is also easily rinsed away with water. When we wash the cloth with water, so along with the dirt, micelle is going to get washed away. Okay, so this is nothing but cleansing action of soap. And please download the notes that will be in the description. The link will be in the description. Please download it and revise it once again, okay, before you sleep off. All right, I'll see you. We'll discuss the question, question paper tomorrow. Okay, all right, all the best, guys. Don't panic. Okay, we are with you. We really wish you the best. Okay, we hope you remember all of the things that you have studied, and may God bless you. Okay, may you score really well and make your parents, make your friends really proud. All right, good night.